From the University of Arizona comes a report on the research program, a program pointing the way to new horizons of knowledge.
I'm a graduate of the University of Arizona, class of 1948. I returned this year for the annual homecoming activities. While I was back on campus, I discovered much that was new. The university has grown so since I was in school that I was determined to find out how it had grown, its directions and goals. The campus has a new look that is more than its new buildings or its impressive school spirit. I registered as an alumnus and was given a map of the campus. I needed that map because so many new dormitories, classroom buildings, and laboratories have been built since my student days. I talked with several of my former professors, men who have taken part in the tremendous growth of research and extension programs at the university. We looked at Old Main as it appeared under construction in 1890. This familiar building was the original University of Arizona, a single structure in the middle of the desert, about 2 miles from what was then the frontier city of Tucson.
Old Main is now used as a classroom facility for the ROTC, a nostalgic symbol of the university's beginnings. But most of the other old buildings have been torn down to make room for new structures. Eight new dormitories, 5 for men and 3 for women, have been built during the past few years to accommodate the thousands of students seeking enrollment. An impressive addition to the university is the beautiful Fine Arts Center, housing the drama, music, and art departments. Inside the new gallery are several outstanding collections, including the world-famous Samuel H. Kress collection of Renaissance art. The education of students is the primary function of every university. But universities must also conduct research and extend the results of that research to the general public through publications, radio, television, and films. Research is carried on in every department of the university, in the humanities, in the biological, physical, and social sciences, and in the professional schools. On a recent nationwide television program, some of our scientists explained current research projects, such as archaeology and anthropology. Because of our clear air, astronomy has always been an important field of study at the university. Such world-famous astronomers as Dr. A.E. Douglas and Dr. Edwin F. Carpenter have guided this development. Arizona is now to become one of the world's leading centers for astronomical research. The National Observatory will be built on Kitt Peak, 40 miles west of the campus. The University of Arizona also is becoming an important center of research in solar energy. In fact, most of its research work reflects the interest of our people and industries in our physical surroundings. An experimental house is being built on the campus to be heated and cooled by the sun. weather's great effect on the economy of the water-deficient Southwest, the Institute of Atmospheric Physics was developed to study weather processes, especially clouds and rain. In these time-lapse films of Arizona clouds made by the Institute, one frame of film was exposed every 10 seconds, thus compressing several hours of cloud movement into a few minutes' time. These films can be studied for a partial answer to the question, what causes rain? As yet, no one can provide a complete answer. Radar equipment installed on the roof of the engineering building is used to detect precipitation inside the clouds. A visual indication of what the radar antenna is seeing is noted on the oscilloscope inside the building. Cloud photography and radar detection are two of the major research tools being used by the Institute of Atmospheric Physics. Oil smoke is being released from a ground generator to discover if air currents exist that will carry such materials up into the clouds. Periodically, the scientists using this airplane attachment release silver iodide into the clouds in carefully controlled weather modification tests. Airplanes take air samples at various altitudes. By using equipment cooled by dry ice, scientists can measure temperature at which ice crystals form in clouds. There is a great abundance of moisture in the air over the American desert. Scientists at the university and from all over the world are trying to determine how, in some degree at least, the weather may be controlled. The director of the Institute of Atmospheric Physics is Dr. A. Richard Cassander, Jr. Dr. A.E. Douglas, a member of the university faculty for more than 50 years, pioneered the science of dendrochronology, or tree ring studies. An astronomer by profession, Dr. Douglas started his tree ring research as a method of cross-checking his observations of sunspots and their possible effects on the weather. Wood cores are taken from the trees, then the rings are examined in the laboratory. Even samples of charcoal may be examined in this way, providing a 2,000-year record of Arizona's weather of the past and perhaps a clue to the future. Archaeologists also use Dr. Douglas' dating system to determine the age of prehistoric remains. Ring patterns from thousands of tree ring specimens are matched to provide a continuous and permanent record of the influence of past rainfall on tree growth. Dr. Douglas' records indicate that over the centuries, 40-year periods of above-average rainfall tend to be followed by similar periods of deficient rainfall. Dr. Douglas also developed this cycloscope, a machine which provides a visual image of almost any data which can be reduced to periodic formulae. One of the newest classroom laboratory structures on the university campus is the Biological Sciences Building. Well equipped with laboratories for the departments of zoology, bacteriology, psychology, and wildlife research, it also includes a new wing used for biological research. A bacteriologist is inoculating cultures of yeast in order to test their ability to form different compounds. A Warburg machine is also used in these tests. Later, a radioactive sugar is injected into the yeast cultures. This is used for the study of the basic chemical reactions of life and is applicable in the study of such diseases as cancer and diabetes. In the nearby College of Pharmacy, the university has established a Poisoning Control Information Center. Here, there are complete records of all poison substances of potential danger to both man and animal. Hospitals and doctors use this information center, the only one of its kind in Arizona. The pharmacist here is compounding a universal antidote, which counters the effects of most common poisons. Another health-related program was inaugurated at the University of Arizona in 1957, when a school of nursing was established. The student nurses do much of their laboratory work in one of Tucson's major hospitals. Students take alternating assignments in the various wards in the hospitals, under the supervision of faculty members. 2 programs are available in the nursing field, both leading to the degree of Bachelor of Science in Nursing. The first is a 4-year course for high school graduates. The second, a program for persons who have previously become registered nurses. Arizona has an abundance of wild game, and a comparatively new program at the university is in the field of wildlife management. Wildlife management students, in addition to their classwork, spend considerable time in the field obtaining practical experience. Many secrets of a wild animal's existence can be found by using penned animals. Here, wildlife students are building pens for javelina. Wildlife research includes a current study of quail habits and survival. Along with this work, students and research workers are studying the movements of these birds and also their diseases. A disease called bird malaria is carried by this insect. It infects most of Arizona's quail. Research has found that the quail are not greatly affected by it, nor is it communicable to man. This disease is studied by an examination of tiny blood samples. Here, a research scientist takes a sample of blood from a quail before the bird is weighed, banded, and released. Under the microscope in the laboratory, the blood sample is analyzed. The diseased cell is located by its dark ring. The Arizona State Museum is located on the university campus. Dr. Emil W. Howry is head of the Department of Anthropology as well as director of the museum. Students here learn not only in the classroom, but also in the field. Here, not far from the campus, students excavate a prehistoric Indian dwelling. During the summer session, students from all over the nation assist in excavating an ancient Indian community at Point of Pines in east central Arizona. At nearby Fort Huachuca is the Army Electronic Proving Ground. There is a close relationship between Army experts and the university's outstanding Department of Electrical Engineering. In the engineering college, students and faculty members conduct numerous research projects. An electronically controlled automatic weather station is being perfected under one Army research grant. Recently donated to the university was the largest computer memory built today, a machine able to store 35 million items of information. University of Arizona engineers also have designed and made other computers for specific kinds of research studies. Computers on the campus are not exclusively for engineering research. They can be used by faculty members from such widely divergent fields as philosophy, education, chemistry, and zoology. The University of Arizona also has its own atomic reactor in the engineering building. Like the computers, This reactor is available for research projects being carried on by many departments. In the chemistry department, the United States Atomic Energy Commission is sponsoring research on rare earth elements. This work, the first of its kind to be conducted anywhere, consists of analytical methods of determining the nature and quantity of rare earth minerals. Arizona ranks first in the production of copper. Open pit mining, the most widely employed method in the state, makes use of the latest equipment, such as the skip system at this mine near Tucson. Students in the university's College of Mines take numerous field trips to nearby mines, mills, and smelters, and are able to study firsthand both open pit and underground operations. The addition of the new geology building to the mines building provides the university with one of the best training facilities in the United States for the mineral industries. There are laboratory facilities for experimentation in mining, metallurgy, and geology. Here also, the Arizona Bureau of Mines carries out research and furnishes information about mineral resources to the people of the state. The College of Agriculture at the University of Arizona is part of the world-famous American system of land-grant colleges and universities, in which the federal and state governments cooperate in research projects for farmers and ranchers. Range research is done in cooperation with Arizona ranchers and with the United States Forest Service. Feedlot research is done largely on the university's own farms. All of the members of the agricultural teaching staff are also on the staff of the Agricultural Experiment Station. These Herefords are being given a chemical ear implant to determine if rate of gain can be increased. Experimental cattle are infected with valley fever in order to study this disease. Agricultural students take part of their coursework in the College of Agriculture building and part in the field at 10 experimental farms operated by the university throughout the state. In the meats laboratory at the University Farm in Tucson, students learn how to butcher meat animals, and in the process, study meat grading and quality. One of the university farms is devoted exclusively to experimental work with poultry. New equipment, such as an automatic feeder, has been put into the operation. Egg size may be improved only through breeding. Egg quality may be improved by breeding and by dietary means. Both size and quality are checked by a poultry scientist in the farm's well-equipped laboratory. Arizona's crop yield per acre has been increased more than 50% in the past 25 years. This is largely due to the high-caliber experimental work done by the university's scientists. Arizona farmers produce the highest per acre yield of cotton in the world and some of the highest quality fiber, including the famous Pima variety. The University Research Center near Phoenix is a world center for information about this important crop. On the adjacent farm, A great number of cotton varieties are grown in experimental plots and tested inside the laboratory. Both of the common varieties of cotton grown in Arizona, Pima S1 long staple and Acela short staple, were developed by university plant breeders, Professors Walker Bryan and E.H. Presley. The income derived by Arizona farmers from these cotton varieties alone has many times over paid for the cost of the research. Experimentation is vitally important to Arizona's economy, but the research is useful only if the test results reach those who can use the information in everyday practice. So the university conducts field days for farmers, bringing them to the test plots to show them new crop varieties and ways of combating plant insects and diseases. And through youth organizations, farm youngsters receive much of the same practical information provided for their elders. The College of Agriculture also provides numerous bulletins through its Extension Division and Experiment Station. These publications, covering almost every phase of agriculture, are prepared by University Agricultural Research and Extension workers and distributed from the university's mailing bureau. The mailing bureau also distributes each year thousands of copies of publications from other divisions of the university. Herring Hall, housing the Radio Television Bureau, disseminates information of all types to the people of the state. On a weekly farm broadcast, a horticulturist records an interview for release on 9 commercial radio stations throughout the state. While other members of the College of Agriculture staff rehearse a farm television program dealing with dairy science. The university television station serves as a center for production and distribution of television programs. In addition, it is a laboratory for university students enrolled in speech, journalism, and advertising. The film you are now viewing was prepared by the Bureau with the help of students. Even the airplane is used in extending services to all sections of Arizona. Here, 3 faculty members are on their way to teach courses in a city more than 200 miles from the campus. Such extension courses are offered in many communities of the state. Today, there are more than 60 buildings on the campus of the University of Arizona. Many of these have been added during the past decade to serve the additional thousands of students and the expanding needs of the state. Much of university life is colorful. There are spectacular displays for campus visitors. Athletic events which annually attract more than 150,000 spectators. But these, of course, are incidental. The heart of the university is the library, its storehouse of knowledge. Through the educational program, this knowledge is available to each rising generation of students. Through the extension programs, services are provided to Arizona's individual citizens, its farms and ranches, its mines, and other industries. The research program points the way to new horizons of knowledge for Arizona, for the nation, and for all mankind.